All right, are you people ready for some fun? It's going to be fun. It's a very fun talk. So, in Zundert in 1853, a boy named Vincent van Gogh is born. In 1880, at the age of 27, he decides to become an artist. In his early years, he taught himself to draw and paint, but his style changed significantly under the influence of Impressionism. His career was very short though, lasting between 1880 and 1890. Quoting the Britannica biography of Van Gogh, his palette at last became colorful, his vision less traditional, and his tonalities lighter, as may be seen in his first paintings of the Montmartre. By the summer of 1887, he was painting in pure colors and using broken brushwork that was at time pointillistic. Finally, by the beginning of 1888, Van Gogh's post-impressionist style had crystallized. The main painting technique associated with Van Gogh is called impasto, where the paint is applied directly onto the canvas and then spread around. It can even be mixed together with other paints, sometimes using your own fingers. This gives the painting thick, three-dimensional texture, and the paint itself is undiluted. A common practice is to work the paint as little as possible, because the more you touch it, the duller and flatter it becomes with each stroke. The most famous example of this is The Starry Night, 1889. So you can see the timeline here is nearing its end. Quoting again the Van Gogh experience, had the painting been done with flat paint, it would not have been the memorable piece that it is. All right? Cool, I just taught you something. It's time for a quiz. You locked the doors, right? Good. I told you this would be fun. Is this a painting by Van Gogh? Give me hands. Who thinks this is Van Gogh? Nobody. Cool. That's right. Adam van Brien skating on the frozen Amstel River. Not even the same century. All right. Okay, you ready? Pen and papers up. Is this a painting by Van Gogh? Give me hands. All right, all right. Most of the room, yes. Farmhouse in Provence, 1888. Cool. You can see the brushwork here. You can spot it on the grass and somehow the trees as well. Cool. Ready? Is this a painting by Van Gogh? Maybe earlier work? Huh? Any hands? Any brave hands? Oh, I have taught you well. Jonathan Barthold Longkind, Downpath. But this is the same area. Also Dutch, but same general year. Ooh. All right. Is this a Van Gogh? Brave hands? No brave hands. Unfortunately, this is Van Gogh. Crab on its back. You can see the brushwork. I have not taught you well. No. It's okay. So, hi, my name is Ólafur Waage. I'm a senior software developer at Factlines, and this is my handle on most social media. If you do @OlafurW, you'll find me everywhere, and you can yell at me after the chat. You can totally yell at me. I work for a company in Norway called Factlines. We deal with company regulations and supply chain tracking and that kind of fun stuff. Yeah. So, this talk is titled Learning Rust the Wrong Way. And it's good to start with a philosophy quote, because then you can be like, if you're learning, you can have some hoity-toity quotes, right? So what's wrong with knowing what you know now and not knowing what you don't know until later? And this is, of course, the philosopher Winnie the Pooh. So, as some of you might be thinking, what's going on here? Based on the title talk and introduction, this is not a normal talk. The structure is a bit of an experiment on my end. And yes, you will learn some Rust. Don't worry about that. You will also learn about learning, and also learning the wrong way. This talk does have a point, but I might go the the back route to get there, all right? And since we are programmers, and I titled the talk, Learning Rust the Wrong Way, let's be literal. Let's learn wrong ways to learn Rust. Yeah, while skydiving. Do not learn Rust while skydiving. I do not recommend it. You will probably not learn much because you are busy doing something else. Good. As an 18th century aristocrat, I do not know why they have Windows 11, but I would not recommend, because they probably don't have power, and yeah, they're busy doing other stuff, right? So I do not recommend. This is probably a wrong way to learn Rust. Good. Just to give a talk at a technical conference. We can skip this slide. Good. So, what is Rust? Rust is a programming language focused on performance, safety, productivity, and here's a function. You say fn for function. Here's the main function, fn main. Here I have a variable. I say let float. It's an f64, so it's a double. Let's say 42.0. So now I have a variable called myFloat. That variable is const by default. So if I want to mutate the value, I have to say let mut. So now it's a mutable variable that I can then change later on. I can ask questions. So you can see that the unnecessary parentheses, they're not there. So you can ask a question about the float. Is it bigger than 40? If it is, I would like to change value. And I have a print statement. The exclamation mark after the print statement means it's a macro. Macros, a nice way to think about it, it's kind of like a function, but it's defined in a different way and it's run in a different time in the process. But yeah, if you see an exclamation mark, it's just a macro. So here we have the basics. We have functions, we have variables, we have conditionals, and we have some other utility functions. Cool. All right. So in 2006, it was a personal project by Mozilla employee Graydon Hoare. In 2009, turned into a Mozilla-sponsored project. 2011 is the first bootstrap version. Who here doesn't know what a bootstrap is? Yeah, that's when you compile the compiler with the same language. So usually they're written in other language to begin with, the compiler, and then you write a new compiler with that language. So you pull yourself up by your own bootstraps, all right? That's usually a big milestone with a compiler. And then 0.1 is in 2012, so that you can start to use it a little bit. Some more code examples. So here I have the value. It's a 32-bit integer. Here I then call a function, and I pass in my value with the ampersand there. And I also pass in another value, all right? We haven't seen the function yet. And then I print out the new value. So from this, just this part, what do you think is going on here? Is it just getting the value? Is it mutating the value? What's going on? Who's here for mutation? Yeah? Cool. So I borrow the value. Here's another example of a function that takes in a value. Here's the type, and then the arrow is the return value. So it's a fn borrow value. I take in the value by, then this is by reference, and then I return the value out. If I take a thing in by reference, I need to dereference it. So this is similar to C++. So I get the value out. I'm basically copying it into a new variable. And notice it being copied into a new mutable variable because I would like to change it. I change it in some way, right? And then instead of saying return, the last statement in the function is the thing you return. And there are many things that are statements in the language. This is just a very simple one, which is just a variable. So you can have other things that are statements, but the last statement in a function is the thing you return. You can do return, just like other languages. So if you have a guard clause at the beginning, like, hey, if the value is smaller than 10, go away, right? So you can say, if it's less than 10, return 0 or something. That's fine. You can do that. Cool. This is happy. This is fine. So, because I talked about borrowing and mutating, it wasn't mutating. So here I have a mutable reference of i32. So this is now saying the variable that's coming in, it's a reference to something outside, and I'm allowed to change it, right? Okay. Who thinks this works? We have heads shaking. Yes. So this is a thing, when someone is new to the language, they will hit their head on. They will say, these types differ in mutability. I'm sending it in as a reference, but I'm expecting a mutable reference. Now that matters. That actually matters in the language. So knowing what is mutable, what is not mutable, what is the state of this object in the world matters very, very much. While in other languages like C or C++, if one variable is mutable or not mutable, doesn't matter, all right? So here we have another fn. I have a value which is mutable. How much is some other value? And I would like to change my value by how much, all right? And again, like I'm showing you this way of like passing it in. This is a very C or C++ way of doing things. Kind of deliberate just to show you the edge cases, but please just use values. Please use values. Anyway, so we have a value. It's a mutable i32. I have a reference to an i32, and I would like to change the value. And I don't even return anything. So I'm actually mutating the value from the outside. This is fine. This works. But if I do this, I first send in the value as a reference, and I also send it in as a mutable reference. So I'm sending the same variable in twice, right? So in line 9, mutable my value and then a reference to my value. This doesn't work, and it will tell you, because you cannot borrow my value as immutable because it's also borrowed as mutable. So for those who have worked with like single writer, multiple reader mutexes, think of all variables as that kind of paradigm, where if you have a mutable variable, only one thing within the system can be mutating it, and nobody can have a read towards it, okay? So this is kind of the big wall. If you've worked with lower level languages and that kind of thing, this is a big wall that you will hit with this language. And what it's telling you is, this is risky and this will cause you problems. And this is kind of a step into the idea of safety within Rust. This is just one part of it, but this is kind of a easy explain version of this. So yeah, cool. Now I've taught you another thing, good stuff. Let's talk about baseball. Who here likes baseball? Any fans? Is baseball big in Australia? I don't know. No? I should have done cricket or something, but no, I'm sorry. The papers I have is about baseball. So, hitting a baseball is a relatively complicated skill. You need the speed to recognize what kind of ball is being thrown. You need the precision to hit the ball, and you need the strength to make sure it goes as far as possible, right? In 2018, the batting average of baseball players was 0.248. So this means that the average baseball player had a 24.8% chance to hit the ball. This is not per hit or per it's per attempt, because you can have 3 strikes and 4 balls or something like that. So you have a session on the stand. During that session, you have a 24.8% chance to actually hit anything, right? Doesn't mean it goes far, just to hit. Okay. Yeah, the thing I just said. There's more to it also, something about the calculations, but generally, yeah, this is the idea. Only thing you need to know. Cal Poly Mustangs are a baseball team that represent the California Polytechnic State University. The team was founded in 1948 and has competed in the Big West Conference since 1997, and they even won it in 2014. Cool. In 1994, that same university published a paper by Hall, Dominguez, and Cavazos called Contextual Inference Effects with Skilled Baseball Players. This is a very interesting paper. The study took a group of baseball players and measured their batting averages. Get a baseline. Good. The idea was then to give them extra batting sessions for 6 weeks. You have your normal training, everybody has their normal training. Let's give them extra training, okay? So, I call this a baseball study. They were split into 3 groups. One of the groups was thrown balls in a structured order. So they get 45 balls. 15 of them are fastballs, 15 are curveballs, and 15 are changeups. Fastball's direct, curveball kind of sways around. A changeup is a ball that looks like a fastball, but then halfway through it swerves. So it's like a delayed swerve, I think. And they were always thrown in this order. So they get the first 15 fast, then the curve, then the changeups. And this is usually called blocked practice. I know what I'm going to practice. This is the thing I'm going to expect. I'm putting the exercise into structured blocks. Good. The second group got the same number of throws, but the order was random. So they had no idea except if they were counting in their heads and they knew the last ball, right? Sure, but generally no, they don't know what balls were being thrown. And then the third group was control, and they did not get any extra practice. Sad for them, but that's life. Cool. So, how do you think? Again, a lot of audience participation. What do you think happened? After the 6 weeks were done, we had another test where 45 random balls were thrown at the group of players. The control group improved by 6.2%, okay? So for the other ones, you can plus minus around 6% for that one, okay? What do you think happened? Blocked group, the ones that knew were coming, improved by 24.8%. What do you think happened to the random group? 56.7%. They did not know what they were practicing for. Some might think, shouldn't the blocked practice help more, right? Because in the random practice, you don't know what you're practicing for. This is weird, at least to me as well. You have no way to prepare. You have no way to create any mental model for what you're doing, any muscle memory. Like all the things that are happening here, this doesn't make sense, right? So we'll get into this. So what's going on here? I wanted to learn Rust. And I had this idea, hey, I'm a programmer. I have certain set of skills. I have some experience with programming. This should transfer, right? I've done this for years, right? Decades even. Learning another language, like really learning it, should be easy, right? I've done this before. It did not work. So to go on the yak shaving trip, instead of learning more Rust, I'm like, why doesn't this work? Why am I not learning, right? When I'm just casually learning or playing around with the language. So, and this is not the jab at the idea that Rust is difficult, right? There's a feature in Rust where you have to tag the memory of like, where is the lifetime of the thing? I have written projects, I've written an entire Sudoku game. I did not use it once. Because like with any other feature, if it's not useful and I don't need it, I don't have to use it. So sure, I might have to learn a bit more then, but that's not integral to the thing. And it's not an idea that Rust itself is hard, right? Sure, there's tricky things like I mentioned before. That's not the point. This is a jab at my hubris that I thought, hey, I have these skills. This should be easy, right? What I found out that I did not actually really learn Rust until I really sat down and I really sunk my teeth into it. Why? Doing a tutorial here or there, tiny project, whatever, didn't help, right? So what's going on? And yeah, as a curious person, like any programmer, I wanted to know why. Let's talk about Pokemon. Any Pokemon fans? Okay, cool. Okay, and Rust as well, that's fine, sure. So after going through some exercises that covered the basics of Rust, I started to look at older projects that I had made in C++. So this is a great exercise if you're learning another language. If you have some bit of code that you had before, convert it to your new language. That's a very good exercise because it will show you where you will hit your head, like a thing you haven't spotted that you haven't learned yet. So convert it over to Rust. Yeah, this is a great technique. The only thing, for those who aren't Pokemon people, the only thing you need to know is that they have types, like fire, water, electric, grass, yada, yada. And if a water Pokemon is fighting a fire Pokemon, they do twice as much damage. Or if a ice Pokemon is fighting a water Pokemon, they do half damage, right? That's the only thing you need to know. And Pikachu is electric, if you want to know. And that's also I was ahead of the generation for that. So that's, I don't know Pokemon too much. But it's an interesting thing, this kind of chart, because you can make these kinds of things. This is a little simulation of Pokemon fighting. So each pixel is one Pokemon. They look around at all their neighbors and say, who of my neighbors is weakest to me? Then I will attack them. If they die, because they have a little bit of health points, they convert over to my type. So if I'm an electric type, I look around like, here's one that is weak to me. I attack and kill them, they turn into electric. So you should see kind of like flow behavior or that kind of patterns that are happening, right? This is the C++ version. The big issue I had with this one was there was one bug that I found later after this GIF came out, but that's fine. And the colors don't match, which kind of annoyed me afterwards, but the colors will be correct in the Rust version. And the Rust version will look faster. It's not necessarily faster, it's just the GIF is faster. So don't worry about that. But yeah, this is kind of cool. So let's look at very complicated C++ code. So I have a grid by grid. So whatever the pixels by whatever pixels. So 512 by 512 or something like that. I have an array of Pokemons. I will fetch out one of the Pokemons, get a reference to it. I will then find out where I am, and I will find the weakest neighbor. I have a function. I get where I am, who I am. Give me my weakest neighbor. So this function will turn out the weakest neighbor. I will find out who they are. So this is where they are. So I will get the reference to them. And then I say fight. I have Pokemon A, Pokemon B, go into the fight function, right? Very complicated. And this is main part of the code. Rest is just printing out stuff. Cool. So this is the Rust version. Again, it's faster, but don't worry. You can see that here, I think the dark blue one is a thing called dark in Pokemon. The yellow one is Pikachu. So you can see Pikachu there having fun. But you can see like this wave of a thing is better than another thing. So when the dark blue starts to dominate, you can see the brown and then the pink. So you can have like this wave of behavior. This is sometimes used in game development, where if you want to check, is your game balanced? So you run these simulations. So this is one of the type of simulations you can run. And you can see that there are some problem spots. And what you can do by those problem spots is you make them rarer. So if you see like, oh, the dark blue can dominate, so you make them generally rarer in your system, so then they shouldn't. It's like, this is kind of virus behavior as well, right? Kind of interesting to look at that. I have a repo of this for the Pokemon, where I also implemented rock, paper, scissors, and Street Fighter, what was it? 3 alpha, I think. I found a graph. Because anytime you have like this kind of table where you know a thing is better than another thing, you can implement this very easily. So it's kind of fun to look at. So let's look at some Rust code for this. So here I have a class. So let's look at classes. I have a class called Pokemon, and they have health and damage, right? So here I have a class. And the thing you might then notice is the implementation of the class is separate from the class. So you have the structure of the data, and then the implementation of the code for the data. And then you have the new function, which is the constructor, and it returns self. And here is an example of the last statement in the function is the return value of the function. So here I am creating a struct called Pokemon, and there's no semicolon at the end, because this is the thing I'm returning from the function, right? So this is the final statement, and then I can just give it some values. So that's kind of explaining what's going on with this function. The Pokemon is just a statement, and that's going to be the thing it returns, right? Here I have a function. So you can see that this function is a part of the class. It takes a mutable self. So you can also say reference to self, and then it takes an argument as well. So we have, like some of the languages, the this or the self is explicit in the function, right? And then I just reduce my health amount, right? Then I can have some code to ask like, hey, is this Pokemon still alive? If not, cool, let's do the replacement part. And that's the battle. And I can have a vector of Pokemons. In this example, I have only 2 of them just to show you. So I have, again, the battle, I have the constructor. I make a vector from 2 of the Pokemons. I just have 2 just to show you the example, but you can make an array or vector or whatever. There's also a macro called vec exclamation to make vectors out of make vectors simpler, right? So here I have a battle, and then I have a fight function. Again, this is mimicking the C++ code. I'm just moving things over. So let's go through all the Pokemons and make them fight. Let's first pick the attacker. That's this Pokemon over here. We get a reference to it. I get the defender, which is just the next one in line. And then I say, hey, defender, you take damage. How many here think this works? You're suspicious because I asked the question, maybe. Because this doesn't work. And this was another wall that I hit, which didn't make sense to me. Cannot borrow self Pokemon as mutable because it's also borrowed as immutable. Because I'm borrowing the vector. Right. This was another thing that didn't make sense to me. Here I am saying like I would like this item from this vector, and I would also mutate this other item from this vector, and then I would want to do something to them. So in my head, these are two separate elements. It's just an array that just happens to be a collection of them. I'm getting references to two of them. I want to mutate one, right? Brush says, no, I can't do that. It's weird. How this was eventually solved is you don't need the whole Pokemon, right? You just need, like, the defender can take the damage. I don't need the whole attacker. I just need to know what damage it does, right? So I don't need the whole object. So this is kind of a design thing as well, right? Because imagine if Pokemon's, the class was way, way more complex, has like images or references to files or names or strings or whatever. I don't need to copy it or get a reference to it. I don't need that in my memory. I don't need that in my cache. The only thing I actually need here is the damage, right? But there, incidentally, it kind of moved me towards a better design for this. But this is another thing that you can have a problem with, all right? Let's go back to paintings, right? So, in 2008, an experiment was conducted in the University of California. How am I on time? Good. The goal of this research was to detect the difference between two teaching methods, massed versus spaced. They were asked to study the paintings grouped by the artist. Massed, so you have only Van Gogh or only Picasso or something, right? Or interleaved. So you have them all mixed together. So you learn all of them basically at once. Each masked participant would get a set of paintings all by the same artist. If I remember from the study, none of the artists were famous. So this couldn't be something you knew before, right? So some local artist or something that you wouldn't know. They would then spend time looking at the style, then the next painting, and look for similarities. So you're saying like, hey, this painter over here, what are they working for? What are their colors, their brushwork, their subjects, whatever, right? So you focus on that. The space participants would just get a mix of all of them, right? Again, the results were counterintuitive because the space version did better. Not slightly better, always did better. This again goes against what you think of like, I want to focus on this subject. I would like to focus on this thing over here. The people who got the spaced thing, basically they got a more complex task. They did better. Not only that, the space version where the participants are not able to study a single painter at a time, focus on their style, was the one that gave better results. So correct identification of the painter. And even, so this is the kicker as well, and even if the masked version did worse, the participants preferred that way of learning. So this is a big thing, because that means if you are teaching something, or if you have a class, and then you have a survey afterwards that says, how did you like this class? Did you enjoy this class? Them saying yes, and you optimizing for them saying, I like this class versus another class, does not mean that they are studying better, right? In experiments 1A and 2 combined, 85% of the participants that did at least well in the space condition as well as the mass condition, but 83% of the participants rated the mass condition as equally effective or more effective than the space version. Right. This doesn't make sense. So looking back at our own inability to foresee the benefits of spacing, perhaps we fell victim to the same illusion that we have railed against. Namely, the illusion that a sense of ease and a sense of fluency accompanies effective learning, where a sense of difficulty signifies ineffective learning. Okay? In the case of this induction, as in many other types of learning, spacing appears to be sometimes, if not always, a desirable difficulty. And this was kind of the key word that I saw in this paper and other papers that I was reading about this, was desirable difficulty. Because, desirable difficulty. We don't want to make things hard just for the sake of making them hard. AKA, this slide over here is not a better slide than the other one. I'll tell you that this is a Caesar cipher of 7, if I remember, right? This is not a better slide. So it's not just difficulty for difficulty's sake, it's desirable difficulty. So again, quoting Elizabeth Björk and Robert Björk about desirable difficulties, they trigger encoding and retrieval processes that support learning, comprehension, and remembering. Or kind of a summary is, practicing easy things is fooling your brain into thinking that you are doing well. I'm sorry. It's not just this study. We saw it also in the other studies we saw before. The thing that seemed harder was the thing where people did better. So make your stuff hard now. I'm kidding. But yeah. So there's also been people looking at learning methods. So empirical studies have looked into different learning methods and strategies that have a positive impact on your learning. So spacing, interleaving, so it's different learning styles, different learning types, variation, like what you're learning and how you learn it. And this I thought was interesting as well, generation. I'll go into this in a little bit. There's another study, excellent. There's another study by Kerr and Booth from 1978, where kids were supposed to throw bean bags at a target. Group A practiced by throwing at a single target, at a single distance. Always the same, practice the same thing. Group B practiced by throwing at many different targets, closer and further away. And if I remember correctly, never at the same distance A was. So if A was 3 meters away, B never had 3 meters away, right? Again, the test was conducted and throwing at the same target Group A used, Group B did better. So they had a harder task, harder practice, harder thing they were doing, and they did better. This is 78. So, back to Rust, or any language. So what does it actually take to learn a new programming language? So, who here? Come on, is it enough to learn what's a YouTube video? No, of course not. Like, if only, right? If only. Read a blog post or tutorial. Like, no? Watch an hour-long conference talk. No, right? Sit down a program, a little bit more hands there, right? Or you need to do all of these and more and mixed and over a long period of time. And this is kind of the annoying hard truth of like there's no easy way out. There's no simple solutions to this kind of stuff, right? Who here, like some of us are older than others, right? Who remembers like learning programming, learning Java in 30 days, that kind of stuff, right? Because if those books really were good, those would have been the survivors. We don't see those books today. Like the 30 days are over, they didn't work, right? Or 10 hours or 30 days or whatever. I sometimes tell, if I'm mentoring juniors is, yeah, you just program every day for about 30 years and you'll be okay, right? You'll get a little better, you'll fail, that's fine, and then you'll get a little better. You might fail again at the same thing, okay, and then we spot the patterns and we move on, right? So, what I can see through the literature is mixing up practice styles, waiting between study sessions. Yeah, you're not procrastinating, it's a studying strategy. Don't cram. This was another interesting study. I didn't include it here, but they had students where they studied similar ways, but one of the groups was allowed to cram just before the test. And there was no, oh, they always do better. Like it was either mixed or worse, right? There was a paper that was just talking or rambling about this thing. So difficult to remember things and then finding the right results strengthens memory. And there was one paper that said, I want you to almost forget everything and then relearn it all over again. And then almost forget all of it and then relearn it all over again. That's not realistic, but yeah. Because then you have to learn it all over again and then, again, forget it. In the 1950s and 60s, there was this concept of errorless learning advocated by B.F. Skinner. Yes, that's Skinner, you might know about. So the idea was that is to give you the information, whatever it is, and then immediately quiz you afterwards. So you're fetching it straight from the short-term memory. So who remembers the quiz at the beginning? Right? That was the idea. I would teach you something, I would give you papers, I would quiz you immediately, you'd probably get most of it right? But how much of it is sticking? in a year, if I would ask you the same questions again, I would ask you like, I would come back here in a year later and ask you what's the painting style of Van Gogh, what's it called? Or even just now, like who can, right? Something with pasta, right? Since then, the opposite has been shown to be true, right? There was an experiment in 2012. It was given kids a set of hard puzzles. These were like anagram puzzles, like find the words around anagrams. You told half of them that it's just going to be hard. Like if they were asking for help and whatever, you just say, yeah, it's going to be hard. Don't worry, it's okay. And then the others, they were like given like instructions or how do you solve it? So let's guide you through this. And the other ones were like, yeah, it's going to be hard. And again, the first group did better. This was a weird one as well. Like we're like, you just have to go through the difficulty of it. So, a question I might throw out there. Is this how we learn programming as programmers, or at least over time? Right? Blocking versus spacing. You might learn about a specific feature of a language we use, or we have them mixed together. Like, you don't sit down and learn variables, and learn only variables, and this is variable day. Maybe some schools do that, but I don't think they do that, right? Variation, different programming languages, programming styles, object-oriented versus functional, different libraries, right? And this was the interesting bit. So generation. So we write our own code, and we read code by others, and we form questions about our code that need to be answered. So the generation style that they found was effective was they would teach the students some subject, and instead of giving them a quiz, the students were asked to form questions about the subject. Let's say you asked them about physics. You ask them, you have to write questions about gravity that you want to be, like, you want someone to answer, right? This is a different way of processing the information. Instead of saying why does gravity work, or what is underlying principles of gravity, you have to say like, okay, you have to think about a question someone might be able to answer. So it's a different way of thinking about basically the problem itself. And we do this as well. And yeah, quizzing. I'd argue that code reviews are quizzes. So we take quizzes every day, which is the question, is this block of code okay? Not only okay is this okay to go to main? Is this fitting our programming style? If you don't have linter, please have linters. Is this the direction we want to go? Even though like the code itself is fine, what it's doing is fine, everything we have tested and whatever, but is this we wanted to go this way, not this other way, right? So is this block of code okay? So, how are we learning Rust the wrong way? Well, the same way we are learning most things the wrong way, by looking for the easy way out. I know I did. And we do this with a lot of little things, because like we are thinking about other things. We have something else on our mind. And I was like, I just don't want to go through the difficult way of doing it. Let's find an easy way and let's move on. We do this a lot, which is probably fine. But if you really want to learn something, the idea is to sit down and learn. You should not look for the easy way out. There's another thing that I've spotted in this. We also fall into the curse of knowledge when teaching. And this is also about fluency, because I find this easy, so it should be easy to explain to others. And this is absolutely not the case, all right? I remember a class I took in university. They got a separate professor to come in to do an hour-long lecture on teaching us pointers. This is a pointer. And they had the box and the arrow, right? And the box talks to the thing and the values over here and yada, yada, yeah. He had an hour on this. And after the hour, I remember walking out and asking a friend of mine, do you understand anything what's going on? And he's like, I have no idea what's going on, right? And then some months later, I had the C book. And I saw the chapter on pointers in the original C book. Like, a pointer is a variable that stores memory addresses. I'm like, oh, okay. And after that, I've known pointers. It's fine. Because it's one way of explaining it. You're attacking the problem this way when it's fully barricaded. And there is another better way to attack the problem, right? So if you think a thing is easy, it's not going to be easy to explain. Absolutely. So, I love puns. What's the rusty key to all this? It took a while to find this photo, but it was good. So it's going to take time, it's going to require practice, and it's going to feel difficult. And that's good, right? Remember, desirable difficulty. Not because Rust itself is difficult, because that's how you get the best results. It's not like learning programming itself was easy, right? If you remember from your youth's first programming. I don't know if it's how it was with BASIC, maybe that was easier then, but I'm not that old, but yeah. So here's another blow to all this. Yes, okay, good. Yeah, here's a fun thing as well, which is particularly good for this conference. Sad that it's on a Friday. It's usually good if I do this talk on the first day. Unfortunately, in this case, there is considerable evidence that in many situations, this strategy, the 1-hour lecture, is rather poor. This is 1971. They've known that the thing I'm doing and what we are doing as a way to teach someone something is not good. A lecture may inspire, it might motivate, and might inform, but it rarely fulfills the principles for effective learning, and it is certainly inadequate for developing high-level skills. What are we doing? Like, what are we doing? We've known this since 71. Like, yeah, this is a great show, and we're having fun, and we're getting like knowledge about different things, but we're not learning. We're dipping our toes more, right? Or watching on YouTube, hi YouTube, right? Like, this is not the way. Yeah, students who studied the topic and then generated their own questions scored an average of 14% points higher on the test than students that used passive strategies like studying their notes and reading classroom material. Creating questions, the researchers found, not only encouraged students to think more deeply about the topic, but also strengthened their ability to remember what they were studying. Here it was. Good. This is new. This is 2020. This is not old. So, all right. This is also why the talk is not an hour, because then I won't have an hour-long lecture, right? Then I don't fall into the trap? No. When Pablo Casales, the cellist, was asked why he continued to practice the cello at 3 hours a day at the age of 93, he answered, "I'm beginning to notice some improvement." Right? And that's my face again. Thank you. Any questions, thoughts, dad jokes, angry rants? I accept it all. Yes, sir.
It was a good talk. It was a good talk about the learning stuff. But I suppose there's still going to be and to that last point, there's still going to be benefit in, practicing a cello 3 hours a day is somewhat block-like, right?
Yeah.
And I know I maybe haven't learned, but I've picked up skills in block learning, right? So shortcuts that people know, I'm like, oh shit, I'm not going to learn it until I just form a block, and every morning, 5 minutes, I try the shortcut. After a week, it's automatic, right? So there are some benefits.
Oh, yeah. So what he's talking about is like, we're not discontinuing blocked. Like, we're not thinking about that, like blocked bad, spaced good. It's like, we have to think about when this studying strategy is being used, it's not the best way, right? It can be effective, it can work. Like you talked about with the shortcuts, like you're sitting down like, no, this is shortcut time. Like, I'm gonna shortcut. Or like, I remember in school, I didn't understand Vim. So I took a day, it was like, this is Vim day. I'm gonna do Vim. And I still remember stuff from that time, like that I focused, blocked on Vim. And those are my main shortcuts from this day. But there's also the idea of, if I had just used Vim every day in a mixed setting for the next 20 years, right, that would also be more effective, right? But this has the issue of, like, there's time element you have to focus into it as well, right? This is like, we're gonna talk about how to analyze painters in general, right? Which is a bigger subject. Like, okay, the shortcuts, more scoped in the other sense of the word subject, right? So you have to factor that into it as well. Like, okay, can we just sit down and just do this thing? Versus, is it a thing that needs 2 years and a university professor, right? So that has to be factored in as well. And again, if you like blocked, fine, go ahead. But just remember, don't quiz people on if they think it's better, because that might not be the better way. Yeah? Any other thoughts, comments? No dad jokes?
What's your opinion on the wrestling exercise?
Wrestlings are so good. Yeah, that's actually how I began. The first thing I did was wrestlings. If you don't know, so there's a repository called Wrestlings. You can clone it, start it up, and it will tell you like, hey, there's a bug in file number, in this file, the line number, whatever. Go fix the bug. And then you fix the bug.
What is it called?
Wrestlings. It's like a...
Sounded like you were talking about wrestling.
Yeah.
Must have missed the first
You're wrestling the wrestling. No. Yeah, it's like the ling is the diminutive, or what's the English word for? Yeah. So it's the little rust. I remember when I went through that whole thing, at least back then, they did not have any memory tagging exercises. I've been told later they've added some, but I went through like, I think 60 exercises. And there was a lot of like, I didn't realize that. I didn't realize that. And it's set up in a nice way where if you run it, it'll tell you like, yeah, there's a bug in file number 1. You go into file number 1, you see like, it's easy, like, oh, there's a missing semicolon or something. You fix it, hit save. It will say like, yep, file 1 is good. Now there's a bug in file 2. You go into file 2 and you move along. So highly recommend. That's how I began with this. And then, yeah, I found like a little project. I moved it over. I found another project. I played a lot with WebAssembly. So I played with that. I did, let me see if I can. There's a Sudoku thing. So this is Rust and WebAssembly. And yeah, you can play a little Sudoku thing. It's not very complex.
an automated solver as well.
Well, so the idea, the beginning idea of this one was, I don't like when Sudoku applications, I don't know how the color does well on this, it does double highlighting. So if I click 2, it's highlighting all the 2s and also highlighting where all the 2s are. So I don't know if it's visible on the screen, but here is the only place where 2 can go. So I can go here, and now 2 is completely solved. If I click 3, this is the only place here. This is the only place here. Boom, 3, 3. It's a very simplified version of it. But this was like, I want to do this kind of stuff. And also, I think I spent maybe too much time on is the UI is fully scalable. And it's not JavaScript UI, it's WebAssembly. So it's OpenGL. So it will, so even the lines are a percentage of the width. So all of the things, and the biggest trick was, how do you get font sizes? And the thing with font sizes is you have to test. Like I have this much space, I want font of 32. Is that too much? Is that too little? Yeah. But yeah. So it's like incremental of like, can I do this project? I did the Pokemon thing. Can I do Sudoku? So I just went along and yeah. Oh yeah, you can play. It works on your phones as well. But it's just it's very simple. The generation has no tricks. It's very like even if I do the tricky one, it looks tricky, it's actually not. There's always one way to fill it out. So it's very basic. But that wasn't the point. The point was just, yeah, learn, practice. And again, just sit down. And this has been a while since I've made this. I even now think like, if I would go back, I'm still like, I need to pick some things up again, right? So, yeah. But I do recommend the Rust and WebAssembly, playing around with that kind of projects. They're very fun. They're very like, yeah. Yes. I think we are, okay on time. Any other thoughts?
How would you recommend the exercise and libraries and stuff to other languages?
In other languages? Because in Rust you have the cargo library thing. Have you seen that kind of stuff? So Rust cargo, oops. We call it crates or cargo. So you say cargo install, and you can say if you want a JSON. Oops, not JSON. JSON. Hello. I didn't. Yeah, thank you. Yeah, so you have a bunch of JSON libraries. And you can see that information about the library, get the docs for it. There's one caveat that, yeah, we have it here. If I say Rust docs. So let's go to the actual, oh yeah, wow, okay. They recommend do the Rustlings course. Yeah, so they have it on the front page, so you can go. Yeah, I recommend it, it's very good. Let me see, Rust library, docs here. So yeah, this is the standard library documentation. This is the library documentation from third parties. So they used to be even similar. They used to have the same thing and everything. That was another thing where I was like, I Googled like, you would do Rust random. We were like, I would like to do random, right? You click this, it says docs.rs rand. You click this, like, cool, Rust has random. No, it doesn't. Rand is a library, you have to download it. Because their decision was, we don't want random in the standard library because random is such a big topic that so easily you can have wrong. But this kind of looks like, okay, if we have them side by side, it's kind of easier to see. But this kind of feels like, kind of feels like the same thing, same setup, same color scheme, right? So you might fall in the trap of like, oh, they have this, like probably not. And the thing I noticed is if they have this menu bar here at the top, then it's not because you can go here and go to the repo, right? So so there's an application called Cargo that's usually installed when you install Rust. And that's kind of, you say cargo run, cargo build, cargo install library, and that's the thing you use. There's even, I saw some talks about like interruptibility between Rust and C++, like calling Rust code from C++ and the other way around. And the main joke I had about that was then, cool, then C++ will have a standard, a package manager. Because then if I want JSON using C++, I can just use the Rust one and call it from there, right? Because otherwise you have this VC package, or you have Conan or whatever else, right? But there's another funny thing you can do if you do XML. There's hard XML, there's strong XML, there's fast XML, there's easy XML, there's quick XML. I just love these names. But yeah. Cool. Everybody happy? Good. Thank you very much.